Hey, welcome back to the Caribou Data Science channel. This is the evening of Thursday, December 29th. This is going to be my last live stream of the year. No, actually, maybe the next last. We'll see what happens Sunday evening with, we got it here. We'll see what happens. Yeah, this will be the last live stream of the year. We may very well start with something on Sunday night, the first, but we'll see about that. But anyway, sit back, relax, enjoy sitting, and I'll be back to you folks in like 15 minutes. Okay, here we go. Welcome back to the Caribou Data Science channel. It's the evening of Thursday, December 29th. This is the last live stream of the year. Sunday night will mark the first. I may come out Sunday night just to start the year off right with a new live stream, okay? I also get, I may in fact be going to Florida someplace for like a month, the last couple months. But of course, I'll take my computer with me so I can keep up to date and continue to live stream, all right? Anyway, let's get started here. Let's just uh, let's see here. As always, you can always see here that just a reminder here, don't panic over the sale. There'll be another one shortly after that. It seems like once a month they have a sale very similar to this, okay? So anyway, let's come back over here. Let's look at, okay? Apparently, Fortran for beginners is the it, it, what's interesting is uh, I only had one written review, and the guy said it was pretty good. Uh, but it's a little basic, which is why it's called for beginners. Let's see some here. Brad Richardson. Let's sort these by highest rated. So here's his first course. Wait, here's his second course. Okay. So I wonder what his intermediate course consists of. 302 students, but only 15 ratings.
Hi there, my name is Brad Richardson. I've been developing scientific and engineering software in Fortran for nearly a decade. Frustrated by how difficult it was to work on some legacy codebases, I learned everything I could about the tools and techniques being used in the rest of the software industry to make their jobs easier, and I started applying them to my work in Fortran. In this course, you'll learn about some of the newer features of the Fortran language and some techniques and strategies you can use to make your Fortran software easier to maintain. By the end of the course, you'll be able to recognize problems in your own code and apply the techniques and patterns that you'll learn in this course to solve those problems more easily and more quickly. Your colleagues and even your future self will thank you because your programs will be easier to understand and easier to maintain. So, if you work on Fortran code of even moderate complexity, join me in the course and improve your skills. You won't be sorry you did. Hi there, and welcome to my intermediate Fortran course. Before we get started, I wanted to go over a few things to make sure you're prepared for the course. First thing, this is an intermediate level course. If you're still pretty new to programming or still pretty new to Fortran, I highly recommend you go back and take my Fortran for Beginners course. If you're not up to speed on all the basics, it's going to be hard to keep up with some of the more advanced concepts and techniques that we're going to go through in this course. Next, I'm going to assume that you've already got a Fortran compiler and an environment set up to allow you to write, compile, and run some basic programs. I'm not going to go back and show you how to get all that stuff set up. Again, if you need help with that, you can actually go and watch the setup videos from the Fortran for Beginners course before you even buy the course. So if you really need to go back and get that stuff set up, you can go get those as well. I will show you a couple of additional little tools that I have set up and am using in this course that you'll notice. They're not required, but they add some additional conveniences that make reading and writing Fortran a little bit easier. But I'll get into that in a little bit. So what we're going to cover in the course are some of the more advanced features and more recent features of the Fortran language, some more advanced software development and design techniques, and some more advanced data structures and algorithms that really can help you write more effective and efficient programs and be a more productive and efficient software developer. In addition, this will make it easier for other people and even your future self to read and understand your programs and reuse pieces of source code from other projects. So I hope you have a good time, and I hope that you find this course enjoyable and informative. I'll see you in the course. In this video, I wanted to just take a few minutes and show you a few of the additional tools that I've installed and set up for my text editor that I'm going to be using throughout the course. You don't necessarily need to have these installed and configured the way I do or at all to make it through the course. They're just a bit of an aid, and they will help make your life easier. So let's jump in and I'll show you what I'm talking about. So the first thing you'll notice immediately is the syntax highlighting. I didn't have you install and configure the syntax highlighting for the previous course for several reasons. Mainly, if you do some programming without the syntax highlighting, you notice just how much easier it is to read and understand the code once you have it turned on. And you won't be lost if you're trying to help a colleague and they don't have some syntax highlighting configured and some other things. So let's jump in and I'll show you how to get this stuff actually installed and configured. So I'm using Atom, the same text editor I showed you in the previous course. And to install plugins, you'll hit Edit, you go to Edit and Preferences. And for installing the plugins, you'll go to Install, and just search for Fortran. And the first 4 that come up, I don't use the Fortran compiler, but I do use IDE Fortran, Language Fortran, and Linter G Fortran. So I'll show you the settings that I have for each of these. So Language Fortran basically just gives you the syntax highlighting. So, and a little bit of some of the auto indent and some other stuff, some niceties about writing code in Fortran. There's really no need to go in here and change any of these settings. You can read through and take a look at them and see if there's any that you might like to change, but for the most part, the default settings are all just fine. Next, the Linter G Fortran package. This package actually executes the compiler in the background while you're writing the code and will show you errors and warnings before you actually go over and try and compile the code yourself. So the default for the first line here is looking for where it's going to find the compiler. The default is usually fine. If you've got some more advanced setups, then I assume you'll be able to figure out how to find what this needs to be set up as. For the flags, though, I recommend these first 5. They will compile the code with all of the warnings and error checking that it can possibly do turned on, so you'll be able to see all of the possible warnings and errors that the compiler could possibly tell you about. And then the rest of this stuff is more advanced, so don't worry about any of that stuff for now. And lastly, the IDE Fortran package. This one actually has an external dependency. It needs the Fortran language server, which is a Python dependency. It's a Python package, and so if you have Python installed and you have the Python package manager pip installed on your system, you should be able to just run pip install Fortran-language-server to get that installed, and then this package will work as well. And I'll show you how all of this stuff is going to work. So once you've got all of those installed and configured, and you've got the external dependency installed, then you'll see obviously the syntax highlighting, which we already talked about. It's also going to do auto indenting for you. So I've already written a little hello world program here, but you'll notice when I hit return on the line, the program line, it's automatically indented 4 spaces for me the next line. So this auto indenting feature actually helps you really keeps your code a lot more readable. One of the things about the Liturgy Fortran, if I start typing another line of code, let's say I want to put x equal 1 down here at the end of my program, you'll notice it's going to pop up this little red symbol here, and it says symbol x at 1 has no implicit type. This is coming directly from the G-Fortran compiler. So without even having to come over here and try and compile the code, I can see what the error it's going to be telling me is, and it's pointing me right at the line. I can see the whole context, and so this becomes really helpful to spot errors before you even have to jump over and try and run the compiler. And lastly, that IDE Fortran package really starts to come in handy when you're starting to write the code. So for example, I want to, this would be unnecessary in this example because the string already doesn't contain any spaces, but quite often, for example, one thing you might want to do is trim your strings to make sure it removes any of the white space. And so if you'll notice, as I start typing, it's coming up with suggestions about what the function I might actually want to call here is. And it's telling me some information about those as well. So if I'm going to call the trim function, I can actually auto-complete that by hitting enter. And then when I put the parentheses in there, it's actually giving me information about what's the argument that it's expecting. And it's telling me some details about what that function does. And so now I can start typing in the name of my variable, and you'll see I also still get some autocomplete suggestions. And it's going to give me the name of a variable it thinks I might want to use, and it's telling me the type of that variable there. And then, so when I hit enter, it will do the autocomplete, and now I've already got a functioning program. So with a lot fewer keystrokes and a lot more confidence that I'm actually getting the things that I want, referring to the right variables, calling the right functions, all of that stuff. And I can do hover over these function names, and it'll still tell me that same information. So all of those tools, getting all of those tools set up, again, isn't strictly necessary for writing the code, but it does make writing and reading the code a lot more convenient and a lot easier. So if you get a chance.
Okay, let's come down here. Can we find out anything else about it? 302 students, but only 15 ratings. That's not a lot of ratings. So what's interesting is we don't really see what's being covered in this course, do we? Here we go, what you learn, introduction, additional setup, procedural attributes introduction, pure and elemental, sum of first 5 primaries compiled, multiplied by 3 and squared. Recursion, recursive sum, abstract interfaces, pretty heavy duty stuff, I think, here. Write sum using reduce, data structure introduction, linked list, write a visitor for summing, heterogeneous list, trees. What do you think? Log in. Hmm. Guess the password, right? Now you'll see I actually have the 2 or 3 courses are actually in progress. Okay, my learning, as you can see, a bunch of stuff here. Let's get started learning. Fortran. Let's just go ahead and take this, shall we? Buy now.
Hello and welcome to Fortran for Beginners. This is a brief introduction to let you know what you can expect from the course and just to introduce myself. My name is Brad Richardson and I am a nuclear engineer and a self-taught software developer. This course is for anyone who wants to learn Fortran, and we'll be starting at a level assuming no programming experience. So even if you have no programming experience at all and aren't even particularly good with computers, we'll still be able to help you get started. If you've already been programming for a while, we'll still get into some material that's new to you pretty quickly. You'll need a computer running either Windows, Mac OS, or Linux, and you'll need 3 pieces of software installed to get started. You'll need a terminal or a command prompt, a Fortran compiler, and a text editor. Don't worry if you don't have any of that software installed. The first lesson is all about getting you set up. By the end of the first lesson, you'll be able to write, compile, and execute a simple program. By the end of the course, you should be able to write programs of moderate complexity. Expect to get confused along the way. If you've never programmed before, some of these concepts may be somewhat foreign at first, but don't give up. The majority of programmers still resort to using a search engine to look up answers to even some of the most basic questions. And you won't remember every piece of information, but you don't have to. The programming community is a very welcoming one, and any questions you have will have been asked and answered in a variety of ways in many public forums. A quick search will usually yield answers, so don't be discouraged. Additionally, some problems may be tricky at first, and your first instinct may not always be the best approach. There are always many ways to approach a problem in software, and no one approach is always the best in all cases. It won't always be clear that one approach is better than another. If you hit a roadblock, it can often help to take a break and work on something else. A fresh look can often yield new insights. Good luck, and I hope you find this course both challenging and fulfilling. Hello and welcome to the first lesson. In this lesson, I'm going to show you how to get your computer set up and write your first program. There are 3 things you're going to need in order to write a program. You'll need a terminal, a compiler, and a text editor.
Now, I'll just point out I got G Fortran and VS Code, okay, on Windows.
A terminal is basically a textual interface to the computer. You'll type in commands, and those commands will be executed, and any outputs will be shown in the terminal, all in text format. The next thing, a compiler is a program that takes the source code that you write and turns it into a set of instructions that are understandable by the computer, i.e. a program. And the third thing, a text editor, is basically exactly what it sounds like. It's a program that allows you to write plain text. There's no formatting, no fonts to select, no bold or italics, no color, no nothing. None of that, just plain text, which is exactly what the compiler wants to see. So let's get started on getting ourselves set up. Okay, so the first thing we're going to do is we're going to install our compiler and a terminal in one go. We're going to be using a tool called MinGW. So the first step is to open up a browser. Oh, and as a note, I'm starting from a brand new installation of Windows, so there are no steps that should be missing from these instructions. So anyway, open up your browser, and you're going to point your browser to a website, the website at https://osdn.net/projects/mingw/releases. And then on that web page, in the lower left-hand corner, underneath the cookies pop-up, so you just hit accept to get that out of the way, there is the download button. It's a little hard to find, but it's down there in the bottom left-hand corner. So click that button, and it should download that in the installer for MinGW. So once that starts to install, you're going to make sure and run that. So in just 1 second, that should pop up. And click Run. And then that should pop up the installer for MinGW. So we'll click Install, and all of the default options are just fine, so I'm going to go ahead and hit Continue. And this will take a few minutes to download and install. And once it's done downloading and installing, it will open up the MinGW Installation Manager tool. And that's what we'll be using to install the terminal and the compiler. And now go ahead and hit Continue, and it should pop open a new window. And so now we're going to install 3 things. We need MinGW32-base-bin. So click on that and select Mark for installation. MinGW32-GCC-Fortran-bin. Mark that one for installation. And MSys-base-bin. So mark that one for installation. And then under the installation menu, select Apply Changes and Apply. And this will take a decent amount of time to install all of that stuff. Alright, so once that's done downloading, you can click the Close dialog, and we can close both the MinGW Installation Manager and our web browser. We won't need those for a minute. We're going to open up a File Explorer window. We're going to go to this PC, and go to the C drive, and you should see a folder MinGW that was just created when you installed MinGW. And then under the MSys folder 1.0, there's an msys.bat. So right click on that and select Create Shortcut and drag that over to your desktop. We'll rename that to just Terminal. Alright, so now we can double click on this and it should open up a terminal window for us. So there are a handful of commands that you'll want to know for this course. There's a lot you can learn about how to use a terminal, but you only need a handful of commands for this course. One of the first ones is, what directory am I currently in, or what folder am I currently in? And that command is pwd, print working directory. So I'm in the home username, in my username directory. Next, ls, what files are currently exist in the directory that I am in? List the files. There's nothing in this directory right now. So next, what we're going to do is we're going to make a folder that we're going to start keeping our programs in. So we will type the command mkdir, make directory, Fortran for beginners. You can name it whatever you want. Just if you use spaces, you'll end up with 2 directories. So if your name contains spaces, you need to put quotation marks around it. So that should make a directory, and now when we type ls, there we go. And now we also need to make sure that our compiler is working. So to check that, we're going to type the name of the compiler, gfortran, a space, 2 dashes, and version. And that should report the version of the compiler to us. If you see that, then your compiler is installed and working. So next, we're going to install our text editor. So we're going to open up our web browser again. And this time we're going to go to the website atom.io. And there on the front page is a bright big yellow download button. So click that and select Run. So this one will take a little bit to download, and it should start installing automatically. You'll see a little pop-up window that will say Installing Atom, and that will take a little while to download and install. Alright, so once it's done downloading and installing, it should go ahead and automatically open up Atom. You can go ahead and register as the default URI handler for atom:// so I'll go ahead and hit yes. You can close the welcome guide and uncheck the show welcome guide, and I'm not going to go ahead and, because this is a different machine, so I'm not going to send my usage data. And you can close the Untitled tab. So now we've got Atom open. I'm going to go ahead and open up the settings. There's lots of settings to go through here to customize this a whole lot, but I'm just going to go over to the editor settings and change the font size for you guys so it's a little bit easier for you guys to read. So I'll go ahead and hit up 18 for that. Now we can close our browser window because we don't need that open anymore. And we can close the File Explorer window we had open earlier. So I'll go ahead and pull these both open side by side and close the Settings tab. So now under the File menu, we're going to say Open Folder. We're going to go find that folder that we created to keep our programs in. Remember, that's under this PC, under the C drive, under MinGW, under MSys 1.0. There's a home folder, and then it should be your username, and then it should say Fortran for Beginners, or whatever the name of the folder you created. So click Select Folder. That should open up that folder. And now we're going to create a new file. So I'm going to right click on that folder there and say New File, and we will name it hello.f90. The .f90 says this is a Fortran source code file conforming to the 1990 or later syntax standard. And now inside that file we're going to type program space hello, hit enter. I'm going to put 4 spaces, print space asterisk, comma, quotation mark, hello world, and hit enter and go back to the beginning and say end program hello. And then I'm going to hit Control S to save. And a handy little tip, if I forget to say that I'm saving the file, this little blue dot will disappear.
As you no doubt notice, he doesn't have what's it called, the intermediate or non-implicit. Implicit, he doesn't put implicit uh, none up there. So we'll kind of follow that and see if in a later and more as we go along, if he doesn't actually add that into it up there. Okay?
Disappear when you save. So if I hit Control S, you'll see that little blue dot disappear. That means that if that blue dot is up there, it means you have unsaved changes. So when you see that little blue dot disappear when I'm in the middle of something, that means that I've just saved the file. So now that we've got that file created, we can come over back to our terminal. Oh, right, we're going to need to change directories into the folder that we created. So that's the cd command, change directory, the name of the folder. And so now when I see what folder I'm in, you'll see that I'm in that folder. And now we're going to compile our program with the command gfortran space hello.f90 space -o space hello. And that will take just a second to compile our program. And then when you type ls, you'll see that it's created the file hello.exe. So we're going to run that program with /hello.exe. And you should see hello world printed to the terminal. That means you've successfully created, compiled, and run your very first Fortran program. So now, before I close all this down, I'm going to suggest that you right-click on the Atom window and pin that to the taskbar. That way it's there for later. And just as a matter of making sure you can get back to here so that you can start on the next lesson, I'm going to close my windows and then make sure that I can reopen both Atom. Make sure that that opens back up. And by default, it should open back up in the last folder that you opened. So you can see there that it's got my Hello World program back open, and make sure that the terminal still opens as well. And then make sure that you can remember to change directories into your folder. Make sure you're there. So if everything is working like that, then you should be ready to continue on with the course.
So let's create let's create a new folder called for okay. For beginners. So this is the first course. Let's come back over here now. Let's go ahead and start the quiz. Let's see. What are the three pieces of software necessary for this program? A terminal, a text editor, and a compiler. Next, compile, explicit none, compile and run the following program. What does it output? If don't know what caused that. Okay, so let's do a terminal. Hmm. Okay, so to use the hex or character ID. So character 87 is obviously W. Although one of these things probably also sets up capital letters. The slash is probably concatenate.
Hello and welcome to the next lesson. In this lesson, we're going to talk about common compiler errors. When first starting out and even long into your career, you will frequently encounter and make common typos, mistakes, other simple errors when writing programs. This lesson should help familiarize you with some of the more common errors and the messages that the compiler will give to you to provide.
Okay, I think the character is a reference to ASCII character. Okay, so it's ASCII character 87. It's either bold or it's W. Okay.
Feedback to help guide you into figuring out what's wrong. Uh, the list of things I'll show you, of course, is not going to be exhaustive. I can't show you every possible error that you might make and every possible message you might see from the compiler, but it should give you an idea of the format, how to interpret those messages, and then where to start looking for the error in your programs. It's quite likely that you will see some code in this lesson that you may or may not fully understand. That's okay. That's not the point of this lesson. The point of this lesson is just to get you familiar with messages from the compiler so that hopefully you won't be as frustrated and scared by them. So the first thing we're going to talk about is some typos. Compilers are very strict with regards to spelling. A single typo somewhere and your program will no longer make any sense to the compiler. Luckily, most modern compilers are pretty good about telling you where your errors are. So let's get started taking a look at some of the errors that we might make and what the compiler might tell us about those. So I'm starting from the exact same Hello World program that we created in the first lesson. So the first thing that we're going to talk about is some keywords. The first program that we wrote, just even this simple little program, has a whole bunch of words, things that are special words to the compiler. So what happens if we misspell some of those words? So to start with, let's see what happens if we misspell the word program on the first line. So let's delete the A and save the file. So let's see what happens when we try to compile our program now. Right? With the exact same command that we used before. G4tran hello.f90-o.
Mm. Well, let's come up here. Now you can run the program up here, but you won't actually get the output. Well, you may get the output. So if you come up here, we say, okay, okay, end of program select. All right, and it says it's not exactly what it says, but it does say error end of file in. This is interesting. So it's saying it was it was expecting secret message one to be down here also. So that's good.
Oh, hello. Ooh, look, we got an error. Okay, it says the first thing it says is on line 1, there is an unclassifiable statement. Ooh, what does that mean? And then we get another error on line 3, syntax error in end program statement. That's interesting.
Here's a question: can I pick an extension that isn't valid for isn't valid? Interesting. Okay, running error. All right, error. Return exit status one. Syntax error. Okay, so it says blah 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 blah. But F088 file format not recognized. Treating as linked script. So I think what it's saying is that this is an acceptable extension. So come back over here. So this should be okay. 2009. No terminal.
And then the third one, unexpected end of file. Okay, so what's going on here? Well, it doesn't know what you mean on line 1 because it doesn't see the keyword program that it's expecting to see. It sees something else and it doesn't know what that means. So it says, I don't know what you mean. That's an unclassifiable statement. And then on line 3, since it never saw the beginning of the program, it's confused about why you're trying to tell it that there's an end of a program. And that's what the last error means as well. Why did I find the end of the file? I never saw a program. So one simple typo and you'll get a handful of errors coming back. The good thing is that very first error is a pretty good hint as to what the problem is. So you take a closer look at that line and you see, oh, I misspelled the word program. I need to put that A back. So now let's go ahead and put that A back. And if we compile it again, if we compile it, we get what we expected and we can run our program. Cool. So what else could we do wrong? What happens if we misspell end on the last line? So let's swap the D and the N. A common mistake, I'm sure, for all of you dyslexics out there, including me. So now what happens when we compile this? Well, we get that unclassifiable statement error again and the unexpected end of file. Well, it was expecting to find the word end, and it didn't. So it doesn't know what you meant. It doesn't know what that word means. So it's an unclassifiable statement. And then it didn't expect to find the end of the file. It expected to find an end program statement, which it didn't. So there you go. So we can now fix that one back, and things would be okay again. All right. What happens if we misspell the word print here? We forget the I. Another easy mistake. Another unclassifiable statement. PRNT is not a keyword it understands. So, due to that typo, there's an unclassifiable statement. So, let's go ahead and put the I back. Alright, what about some other things? User and programmer defined names. So, what happens if we misspell the name of our program on either the first or the last line? So let's start with misspelling hello on the first line. Let's forget the O. What happens? End program hello. Expected label hell for end program statement at 1. Unexpected end of file. Okay. So, because we misspelled the name on the first line, it expects to find the same name on the last line. Since it didn't find that name, that's an error. And then, since it didn't find the end of the program, it didn't expect to find the end of the file yet. So, we can fix that one again by spelling everything correctly. And since this name is user-defined, whatever name it finds here, it expects to find that same name here. So long as you're consistent, spelling doesn't particularly matter in this instance. They just have to be the same. Alright, so next, I'm going to create a new program for some of the remaining examples. You may not understand exactly everything going on in this program, and that's okay. it just gives me more opportunities to show you more potential errors that you might make. So I'm going to create a new file. I'm going to call this enterprise hello.f90. And so this is basically just a gold-plated version of the Hello World program that we've made before, just with more chances to make mistakes. Enterprise hello. And so if you want to go ahead and type these in and follow along, feel free. Implicit none. Character then equals star parameter person equal world character allocatable greeting greet person print greeting contain function greet person result greet function greet character star intent in person character allocatable greeting
It says character only has length. It doesn't appear to be anything. Well, let's call this allocatable,
person,
right? Greeting.
There we go. So this program should function quite similarly to our other Hello World program. In fact, from the outside, you shouldn't be able to tell any difference at all. So let's try it out. Hello. So that compiles, prize hello, and says hello world. Okay, cool. So it does work exactly the same as before. So now let's take a look at some of the errors that we might make in such a program. So first things we're going to talk about is type mismatches. In programming, the type of data you're working with at any given time is very important. For example, it makes perfect sense to add two numbers together. But what would it mean to add the letters A and C? In Fortran, every variable has an explicit type, and every function or subroutine is explicit about the types of its arguments. If you mix these up, the compiler will let you know. For this and the following sections, we'll be using this Hello World program. It performs exactly the same function as our simpler version, but makes more use of more features of the language in order to give us more opportunities for error. So, calling a function with the wrong type. What happens if we try to call the greet function with a number instead of a character variable? So what if we put the number 1 here instead of our person variable? Type mismatch in argument, person at 1, passed integer to character 1. So this function, the greet function, requires a character variable. We didn't give it that, we gave it an integer variable. So the types are mismatched. So that gives you a pretty good clue as to what's going on here. This needs a character and we gave it an integer, so let's give it a character back. And everything should be back to working again. Alright, assigning the wrong type to a variable. What happens when we try to assign a number to the greeting variable? Let me double check. Alright, so what happens if instead of calling this function here, we just said 1. Now what do? Cannot convert integer to character at 1. So why is it trying to convert that? Well, Fortran attempts to do conversion between types in many contexts. Assignment is one of those contexts. Cause of most of these can't convert errors is a type mismatch. So if the variable that you're trying to assign to is character, for example, and you put an integer on the right hand side, those don't match, and that's a problem. In some instances, it may be able to try and convert between the two, and that's why you get the cannot convert error, because it's going to try and convert it, and in this case, it doesn't know how. All right. So let's put back what we had before. What if we forget to give a variable a type? So there's a couple of different possibilities. So what if I just delete line 5? What does Fortran tell us? Symbol greeting at 1 has no implicit type. Did you mean greet? So that's because line 2, we told the compiler, don't assume a type for a variable. That's what that means. Implicit none. There are no implicit types for variables. So because we didn't give this variable a type, it doesn't know what type it is. So it doesn't know what we mean. So we got to put that line back. All right. What else should we try? All right, let's take a look. And how about some syntax errors? This class of error involves all the special symbols that we use to make your program easier for the compiler to parse and understand. These are in some ways similar to punctuation used in English writing. For example, when listing items in a sentence, we typically separate the items with commas, or we use a period to signify the end of a sentence. While writing in the English language, it is oftentimes possible for a reader, a person, to still interpret the meaning, even if that punctuation is incorrect or is missing. But the compiler isn't quite as smart as that. If you don't use the right punctuation, the compiler is likely to get confused, possibly in ways that will report confusing error messages. So, what happens if we forget the first comma in a print statement? So what if we delete that print statement? Or that comma there in the print statement? What does Fortran tell us? Expected comma in IO list at 1. Oh, it tells us exactly where the error is. It expected to find a comma, and it didn't. So let's put it back. How about if we forget a comma in one of our variable declarations? What if we delete that comma on line 4? We get syntax error in data declaration at 1, and symbol person has no implicit type. So it's not entirely sure what we meant, but it knows that there's some sort of a syntax error here. And then because it never saw a valid declaration for the person variable, it doesn't know what type it is, and so we get a follow-on error. So let's put that comma back. What if we forget the closing parentheses when we're trying to call this function? So what if we just delete that parenthesis? Syntax error in argument list. Never found the end of the argument list because we forgot our parentheses. What if we forget the closing parentheses in the function's declaration? So on line 10, we forget that parentheses. Oh, we get a whole bunch of errors now. Expected formal argument list in function definition at 1. So it's talking about the argument list in the function. We forgot that parenthesis. And then for follow-on stuff, unexpected data declaration statement. Well, it never started the start of a function, so it's not expecting these variable declarations. And then unexpected assignment statement. It still doesn't think it's inside of a function, and so it's saying a bunch of stuff it's not expecting because it doesn't know that it's inside of a function because it never saw the proper start to a function. And so we get all sorts of follow-on errors. But the first one is the one that's important. So that's a common theme that you'll see in compiler errors. Is if you make some sort of a mistake, a lot of times it will cause a lot of follow on errors. So, usually, the best course of action is to start with the very first error that you see. Fix that one, and oftentimes that'll fix a lot of other errors that you saw. So, let's go ahead and put that one back. And what if we forget the colon in the variable declaration? So what if we forget this colon here? Syntax error in character declaration, and then the follow-on error because it never saw the valid declaration for the greeting variable. So as you can see, a lot of these compiler errors are pretty helpful actually in trying to help figure out what's the problem. You'll get at the very least you'll probably get what line is causing that problem, and sometimes it'll even point out where in that line the problem is. And the message should give you some indication about what it is you're looking for on that line. So with a little practice and referring back to this video on occasion if you need a little help to see what kind of errors are possible, what kind of error goes along with the error messages that you're seeing, you should be able to get yourself back on track pretty frequently. And occasionally, a Google search of the error message is good as well. And you'll find lots of people who've had similar errors and explained exactly what they did to fix them. So there's no reason to be afraid or frustrated about these error messages that you'll get along the way. You'll make lots of typos and mistakes. That's normal. Even I still make frequent typos and mistakes when I'm writing programs. So just spend a little time practicing understanding some of these so that that will pay dividends down the road when you're in the middle of a long coding session and all of a sudden a compiler error pops up that you weren't expecting. You'll know a little bit. It will be a little bit easier for you to figure out what the problem is and get yourself back on track.
Error, unexpected end of file. Character lengths. I think that's okay. I think it's this one right. Okay, which of the following lines calls the error message error? Expected formal argument list. I think that one's okay. No? I wonder what would, which of the following lines could have caused error? Syntax error in character declaration at one.
In this lesson, we're going to be talking about the basic structure of a Fortran program. This is another one of those mostly just resource material type lessons, but I promise that in the next lesson we'll get around to writing some actual code. Fortran is one of the oldest computer languages. Fortran has also undergone quite substantial changes to its formats, standards, and capabilities over the years. As a result, there are often many variations of acceptable syntax. One of the most striking possibilities is that there are two completely different formats for the source code of Fortran, one called fixed format and one called free format. In this course, I'll be using free format, so you won't need to learn about the peculiarities of fixed form to complete this course. If you are curious or ever encounter fixed form code, there are plenty of resources out there for learning more about it. Every Fortran program has the same order of statements. Some sections and statements are optional, but if they are present, they must be in this order. The only strictly required statements are the beginning and end of the program. However, without any executable statements, the program doesn't do anything. There's nothing explicitly separating the sections either, but if you get anything out of order, the compiler will give you some errors. The variable, derived type, and interface declarations may also be in any order within that section. However, derived type declarations must come before any declarations that use them, and we'll get more into the specifics about derived types and interfaces later on in the course. Executable statements are those statements in the program which actually perform some actions. They can be variable assignments, subroutine calls, control structure statements such as if or do blocks, or a handful of other executable statements. Functions and subroutines, collectively known as procedures, may be declared within a program to allow for code reuse, and they must follow a contain statement. And then the program ends with an end program statement. So let's get into some of the specifics of the syntax. Quick note, any of the optional code will be inside square brackets, so optional pieces of syntax. So there are several general syntax rules which are applicable in all places throughout the source code. One of the most important is that Fortran is case insensitive. That means that all of these statements are equivalent. That isn't to say that you can't or even that you shouldn't use capitalization to signify meaning to human readers of your code, but you should be consistent. And remember, the compiler won't distinguish between capital and lowercase letters. Additionally, white space is not important to the compiler. Any spaces between things aren't necessary for the compiler. Also, indentation is not significant to the compiler. Again, that doesn't mean that you shouldn't use space and indentation to signify meaning to human readers of your code, like these two sections. These are identical to the compiler, but much easier for a human reader to understand what's going on the right-hand side. Next, line length is also important. And a statement can be continued on the following line. A standard limit on line length is 132 characters, but it is highly recommended to try and stick to less than 80 characters to aid in readability. A statement can be marked as continuing on the following line by ending the line with an ampersand symbol. And comments. Anything following an exclamation point symbol is ignored by the compiler. The general convention for most programmers is that short comments pertaining only to a single line will be placed at the end of that line. Otherwise, it's common for a comment to precede the lines to which it is referring. Mostly, comments are useful to describe why a piece of code was written, or why it was written that way. As you get better at reading and writing code, you'll find it easier to understand and express the what and how in the code itself. There are ranges of opinions on how many comments are appropriate in code, ranging from there shouldn't need to be any comments because the code is self-explanatory to every single line should have its existence explained in a comment. You'll inevitably form your own opinions about comments. My recommendation is to think about somebody of a similar skill level to you coming to read your code when you're no longer around. What kinds of things do you think that person might like to know about that code that they probably wouldn't be able to easily deduce from reading the code itself? Alright, now, program and end program. The program statement at the beginning has only one format. Program, the keyword program, and a name. That name can be whatever you like. It must start with an alphabetical character though, A through Z, and must only contain alphabetical characters, numbers, or an underscore. For the statement at the end of the program, both program and name are optional. However, if name is included, it must match the one at the beginning of the program, and it has to be preceded with the program part. Use statements. Use statements allow for variables, functions, subroutines, type declarations, and interface declarations to be kept in modules, which can then be reused in other modules and other programs. The use statement has this syntax. There's several things going on here. By using the intrinsic qualifier, this signifies that the module must be one provided by the compiler, not one written by the user. By using the only qualifier, only those things listed explicitly are available within the context of the place the use statement is included, not necessarily everything that is available from that module. Without the only qualifier, all those things that are public within the module are available. By using the new name, arrow, old name syntax, you can actually specify that the thing referred to by old name inside the module will actually be referred to by new name within the context of this code. For example, if you already have something with that name and you'd like to refer to it as something else within this context, you can actually change the name when you import from the other module. Implicit statements. There are two possible implicit statements: implicit none or implicit type and a character range. If implicit none is included, then no implicit types may be used. If no implicit none is included, then multiple implicit types may be used. A big note: none of the code presented in this course will use implicit types, and neither should you. With implicit types, a typo in a variable name can go unnoticed by the compiler and lead to quite difficult to track down bugs. With an implicit none, the compiler will see a typo as an undeclared variable and let you know immediately that something is wrong. It is highly recommended that all new code use implicit none. You should have an implicit none statement in your code. With implicit type A to Z variables that start with a letter in the given range are assumed to be of that type unless declared otherwise. And if you don't include an implicit none statement, then there are a handful that are already implied by default. So remember to always include that implicit none statement in your programs. Variable declarations are used to specify the type of a variable. Variable declarations have this syntax. The first is for intrinsic types, and the second is for derived types. However, the second can also be used for intrinsic types. We'll talk more about which intrinsic types are available later in the course, and more about derived types as well. There's a lot to discuss about the variable declaration syntax. First, there are a variety of possible attributes that can be included when declaring a variable. We'll get more into those later in the course. Additionally, the double colon is not strictly required in all cases. I recommend including it anyways for consistency's sake, but that's a matter of personal preference. Next, The intrinsic types have kind and potentially some other specifications which can change their precision or length or the amount of space that they take up in memory and some of that stuff. Derived types can also make use of this feature as well. We'll discuss more about that later on in the course though. Next, it's possible to declare the type of more than one variable in a single declaration by separating them with commas. We don't really recommend this when you start to use large numbers of variables. Having them grouped by type tends to be a little bit less important than how they are used and harder to find once there are a lot of them. I recommend sticking to one per line and using some convention for the order you put them in. Alphabetical by variable name works well for me. Finally, it's possible to initialize a variable by having the assignment with the declaration. There is a big caveat here, however. You can only use literals, call a very small subset of intrinsic functions, or use the default structure constructor for derived types. We'll discuss more about the details involved in all of this later in the course, though. We won't go into the derived types and interfaces in this section. For now, just know that they exist and can be in the same section with variable declarations. Finally, the section of the code that actually does stuff. Executable statements really only have a few forms. The simplest is the assignment statement. Some variable equals some expression. A variable followed by an equal sign followed by some sort of an expression. The expression could be quite complicated, but we'll discuss more about expressions later on in the course. Another is a subroutine call. The subroutine does not necessarily require arguments, and in that case the parentheses are optional.
There you go. One thumbs up for the stream this evening. Thanks so much. Hey, if you are watching in the background, hey, just you go and stop by the chat, say hi, tell me where you live and what's going on in your life this evening. Okay?
If it does require arguments, then they go in a list, separated with commas inside of parentheses. Next, control flow statements. There are a handful of control flow statements. Many of them require end statements as well. We'll discuss a lot more about them later in the course. Finally, a handful of executable statements with some syntax specific to each one. There are a number of these, including print, open, read, and some more. We'll discuss lots more of those later in the course as well. Also, finally, functions and subroutines. We'll discuss more about functions and subroutines and the specifics about their syntax later in the course. For now, it's sufficient to know that it is possible to include definitions of functions and subroutines within a program, but they must follow a contain statement. And that's all for the basic outline and structure of a Fortran program.
Come on. What is the minimum number of lines necessary to create a valid program? I'm going to say 3. What? Hmm. Okay. We have to have a beginning and an end to. Okay. Which of the following statements is not equivalent to the rest? Which of the following statements makes all variables beginning with the letter I default to integer? Implicit integer.
In this lesson, we're going to talk about variables. Variables are one of the fundamental
Mm,
building blocks of how programs work. Variables are how your program remembers things. Without variables, the operations that happen early in your program wouldn't be able to affect decisions or operations that happen later in your program. So, what exactly is a variable? Fundamentally, a variable is a way to store a piece of information and then be able to conveniently refer back to it later. Used well, variables can also be descriptive about what the information they store really represents. Additionally, a variable has a type. It is restricted to a specific type of information that it can store. The type of information a variable can store is determined by the type it is declared to have. For example, a variable declared as an integer type can't store a character string, and the same vice versa. Additionally, a variable has a scope. Not every variable can be accessed from every part of the program. Variables in Fortran have what is referred to as lexical scope. That means that the variables can only be referenced within sections of the code in which they are declared. This will become more important, and we'll discuss it a little bit more to help that become a bit more clear later in the course. But for now, let's take a look at how you use them. So we're starting with basically just kind of an example little program here. We've got the start of our program, obviously, and an implicit none statement to make sure I've explicitly declared the types of all the variables that I'm going to use in the program. Next, I declare the variables that I'm going to use in the program. I've declared them all to be of type integer and given them names. Simple little names here because this is just a toy program that doesn't really have much meaning for anything. So I've just called them XYZ. In real programs, usually they'll have meaningful names like feet or inches or name or things that represent real things that you're going to talk about in your program. But for this example, we're just going to use simple letters. Next, I'm going to print the values that each variable holds at each step here. So ordinarily, you wouldn't necessarily do this in your program. You're not going to print the values of the variables after every operation you perform, but this just helps us kind of get a feel for how these things are going to work. So what are you doing with a variable? Basic usage of a variable is basically just give it a value. So that's what we do for the first couple of times. We just give our variables values. Things can get slightly more complicated by using expressions on the right-hand side of the equal sign, like x plus y. These could be 5 and 7, or if what makes the variables useful is that you can actually use them in the right-hand side of an expression. So I've given the values x, I've given x the value 3, y the value 4, so now when I say z equals x plus y, what this is going to mean is z equals 3 plus 4. And then this is just a little trip up to show you exactly what's going to go on in the background here. So let's go ahead and run we'll compile this program and run it. So now we can take a look at exactly what's going on at each step. So at the very beginning of the program, before anything's happened, our variables happen to have the values of 0. After I assign a value to 3, you can see that the value for x has changed to 3. Then we assign a value to y, and you can see that its value changes to 4. Next we assign that value to z. You can see that it got 3 plus 4 is 7. And lastly, when we change the value of x, note that the value of z doesn't actually change. Despite the fact that we said that z equals x plus y, when we later change x, z doesn't change. That's because a variable is only affected when on the actual line of the assignment. And in a little bit we'll kind of go through exactly how all of this works in the background and kind of just step through each step in the program and kind of explain exactly what it is that the program is doing here. But for now, just remember that changing the value of a variable later in a program doesn't affect what happened earlier in a program. Another key thing about variables in Fortran is the value a variable has before you assign it one is not defined. In this example, the compiler was actually nice enough to say, hey, to initialize the values of our integers to be 0. But there's actually an example where the compiler isn't so nice to us. I've got another little example program here that basically just declares a character string variable and doesn't do anything except print it out. So let's compile and run that example. You can see basically what comes out is just kind of garbage. Basically, if before you've assigned a value to a variable, just consider that variable to have garbage. That's just to get good practice to kind of get into, because you can see we can run this multiple times and it won't necessarily be the same every time either. Basically, until you give a variable a value, it's just pretty much got garbage. And finally, what would be the opposite of a variable? The opposite of a variable is called a literal. It's the literal value that appears in your code. Something like the number 3, or a string like hello world, or a real number like 67.8. So when somebody says literal, basically that's what they mean. So you've typed a literal value into the code here. And as the last thing, what if I don't want the value of my variable to change? What if I want to give a name to something meaningful that isn't ever going to change? Let's say, for example, I'd like to say inches per foot. Well, inches per foot is pretty well a defined value. It's never going to change. It's going to be equal to 12. Well, we can give the variable the attribute parameter. And now that value can never be changed. The program starts with that value set and it can never be changed. So we can add in a little print statement here to see what's happening. So now let's go ahead and rerun our little variables example here and see what happened. You can see inches per foot equals 12. Well, okay, well what if somebody comes on later and decides they'd like to change that? They don't really like that. They'd like to put in a statement like this. Inches per foot equals 13. Maybe they'd like a long foot. Well, what's gonna happen is the compiler is gonna tell you the name constant inches per foot in a variable definition context. So the compiler is gonna tell you that's not allowed. This has been declared as a parameter or a constant value. You cannot change it in your program. So in that way, you can kind of protect certain values of your program. These are constant values. We give them a meaningful name and guarantee that they won't ever be changed. So, finally, now I'm going to close out my terminal here because we're not going to use it for the next part that we're going to do here. Let me go ahead and remove some of this other stuff that we had. So let's close out the terminal because we're not going to use it for.
Okay, I'm going to take a 15-minute break here, and I'll be right back after that, okay? And yet you care nothing for the words of God. What did Jesus say? Use the. No, first of all, you should not. Personally, people, these people blast. It looks like my light. Okay. The only explanation we had an injury. Well, this is what you have to understand. This is highly specialized software that already has it. The trouble wasn't. Look, it's like the flu vaccine. The flu vaccine won't keep you from getting the flu. The purpose of was to reduce the chances that you would die of the disease. Okay, welcome back to the Caribou Data Science channel again. let's pick up with this verse here. And I think what we're going to do is this the end of a section? Quiz. Uh, let's just see what happens here. We're about 2/3 of the way through this lesson here.
For a second. And we're going to, basically I'm just going to use a little note-taking app here, and we're going to step through each line of the program and kind of see what exactly is going to be going on here. So I've already kind of gotten started here, but so let's go ahead and just clear this off. We'll just go from the very beginning. We'll kind of start things off. So I'm going to start with a little. You could do this on paper or a whiteboard or something, but for now, just so you guys, just to make things easier to show you guys, I'm just going to use this little note-taking app here. So I'm just going to give myself a little space here to take note of the program's variables. So here's what we're going to do. So I'm going to step through one line at a time here. Well, nothing happens. This is just declaring the beginning of the program on line 1. And then on line 2, still nothing's happening. We're just kind of telling the compiler, hey, make sure we've declared all our variables here. This is basically for the compiler, not really something that's going to happen at runtime. Next on line 4, declare the variable x to be of type integer. So I'm going to give myself a little space here. And if you want, you can give yourself a little hint as to remember what the type of that variable is. Okay, and then on the next line, basically we're going to do the exact same thing. Notice how I didn't put anything on the right hand side of the equal sign over here, because this is exactly what the program is going to do. It's going to go, okay, you've declared a variable, I'm going to reserve some space for it somewhere, which is what we're doing over here on our little piece of paper. We're just reserving some space for it. We're making a note that we have such a variable, but we're not going to give it a value yet. So let's save that part so we can kind of see. Let's take note of what we think our outputs are going to be. So let's just take another text note and we'll call it output. Okay, so now we're on line 8. So we're actually going to output something from our program here. So what do we think this is going to be? Well, it's going to say x equals, because this is a literal string. But what's the next part going to be? Well, it's going to be the value of x. So in theory, we're going to have to go look up our variable here. Well, we got nothing there, so what value should we put in there? Well, if you recall when we actually ran this program, the compiler was nice enough to say that x starts out with the value of 0. Okay, so we'll go ahead and do the same thing here. And then we have y equals, and again, just like the compiler did, we'll just start out with the value 0. Okay, and then, so that was our first line of output. So now let's go back, because on line 10, now we're actually going to change the value of x. So the program's going to look up x, going to go find x and say, oh, okay, you want that to be 3. Okay, so we'll do that. And then it's going to save that off. And then it's going to go on to the next line. Okay, so now on the next line, it's going to print out the values of those variables again. Okay. So we'll move on to the next line. So it's going to be x equal, x is 3 now. And y equals, it's still 0, and z is still 0. And so you can kind of see how we can just kind of walk through this kind of one line at a time and keep track manually just exactly the same way the program is going to do it. And it's going to go back, and for line 14, it's going to go back to look up the variable y and say, okay, you'd like that to be 4 now. And save. And then on line 16, okay, we're going to go back to our output and then put another line. X still equals 3, but y equals 4 now, and z still equals 0. And you can see how long programs, this could kind of get tedious. It would be a little bit faster if you're kind of just writing this on paper and not trying to be as explicit about showing every step. Okay, so now actually Now something a little bit different happens on line 18. So it's going to go look up the value z, and it's going to say, okay, you'd like the variable z to be equal to x plus y. Well, that's not something it knows how to store. It doesn't know how to store x plus y. So now it's going to do something a little bit different. And we're going to talk a little bit more about this when we get to expressions in the next lesson. But for now, just say it evaluates this expression by looking up the values in the variables. So it's going to look up 3 and 4, and then it's going to add them together and get 7. And we'll get more explicit about how exactly that all works in the next lesson. But for now, just know it evaluates that and it gets 7. Okay. And it saves that off. And then we go on to the next line, and it's going to print another line in our output. So we'll go ahead and, okay, so now the next thing it's going to print is still x still equals 3, y still equals 4, and z equals 7 now. All right. And now on to the very last one, to the very last operation that we actually perform. On line 22, it's going to go back, look up the variable x, say, okay, you'd like that to be 1 now, and that's all it's going to do. And then lastly, going to go back and print our output and say x equals 1 now, y still equals 4, and z still equals 7. So you can see now how basically when it goes to do these assignments, the only thing it looks up is what's on the left hand of the equal sign, left hand side of the equal sign. So it didn't even look at z, which is why the value of z didn't change, even though we said on line 18 that z was equal to x plus y. Because by the time it gets to line 22, it doesn't look at the value of z when you only told it to change the value of x. And so that's basically how variables work in a nutshell.
Okay, so we'll go ahead and bring this session to a close here. Thanks so much for stopping by, folks. Hope to see you Sunday evening, January 1st, 8 p.m. Eastern Time.